While we're talking about solution concentration and molarity, it's important to talk about something known as dilution. Now, dilution is the process of decreasing the concentration of a solution by increasing the volume. Remember, molarity is the moles of some solute per volume in liters of solution. So if we increase the volume without changing the number of moles, then the solution concentration or the molarity will go down. Now, we can kind of illustrate that shown here for this solution of copper sulfate. So if you took 25 mils of a 1 molar stock solution and dispensed it into another volumetric flask and then diluted that flask up to the mark, so up to a total volume of 250 milliliters, then what happens is we have decreased the concentration of the solution, as you can see simply by looking at the intensity of the color. We've decreased that concentration down to 0.100 molar solution. Now, what's really important to note whenever we're doing a dilution is that the moles of solute that are present don't change. And we would have to actually lose them from solution somehow for that material to lose. But the number of moles of copper sulfate that were originally in this 25 milliliters, that's the same number of moles that are present in this now total 250 milliliters. And so that's simply the process for our dilution. Now we have a nice equation that helps us to relate the concentration before dilution and concentration after dilution. And that equation comes from the fact that the number of moles is constant. So the moles of solute before dilution are equal to the moles after dilution. And because that is the case, we can rearrange our molarity equation to solve for moles of solute. And if we do that, we come out with molarity time or concentration times the volume. And now if we substitute that in, we come out with an equation for a dilution that you may be familiar with, or you certainly find in your textbook. This says M1V1 is equal to M2V2. So it's the solution concentration of the original solution times the volume of the original solution that you took, that 25 milliliters. That, because multiplying those two together gives us the number of moles, and the number of moles is equal on both sides. So that's equal to the final solution concentration times the final volume. So let's go through an example of this. If we took, what would be the concentration of a new solution if we diluted 25 milliliters of 2.50 molar copper sulfate to 100 milliliters. The first thing we have to do in any of these problems is just identify what goes where. So we need to identify the initial concentration, that's M1, and that is given to us. The initial concentration is 2.50 molar. Then we identify that V1 is 25 milliliters. That's the starting volume. The final volume is 100 milliliters, so that's V2, and we're asked for the final concentration, that's M2. So we have one unknown, M2. So one thing to note with all of these is that because V1 appears on both sides, we don't need to convert the units of volume to liters as they would normally be for molarity. We can leave them as milliliters because the units cancel out. So let's just take here. We've assigned M1, V1, and V2. M2 is the thing we don't know. So we simply rearrange our equation. We do a little bit of algebra, rearrange our equation to solve for M2 by dividing both sides by V2. Plug those numbers in just as they are. The milliliters cancel, and I'm left with units of molarity, which is what I want. Multiply this through, and you come out with a concentration of this final solution as being 0.625 molar. That's how you would use the dilution equation. And it really applies only in cases where we are doing a dilution. We're starting with one concentration, we're increasing the volume to decrease the concentration. Now, another useful technique that comes out of solution concentration is the ability to determine the concentration of a solution that you know the identity of the species that's in solution, but you don't know the concentration. How would you determine the concentration of a solution of acid? And that's where titrations come in. So titrations are a technique that's used to determine the concentration of a solution. These are used when we know what's in solution, we just don't know how much of it is in solution. And here's kind of the general process for how a titration works. So if we're doing the titration, trying to figure out the concentration of some acid solution, we first measure out very carefully a certain amount of the acid solution, and we add that to a flask. Then we add a few drops of an indicator of some kind, something that will simply tell us when the solution is no longer acidic. And then we set up a burette that has sodium hydroxide, that has a base, something that will react with the acid. And we have, in this case, it's a base, and we know the concentration of this solution. It's called a standard solution because we know the concentration of it. Then what we do is we're going to dispense a certain amount. We're going to dispense the basic solution into the acidic solution until the indicator changes color, until the indicator indicates that all of the acid has been consumed, that we have finished reacting with all of the acid. At that point, we know that we've added an equivalent amount of base to react with all of the acid. And then using that information, we can now measure using the burette, we could have measured the amount of base that we dispensed, and we know the concentration of the base, and we know the volume of the original acid. So we can work backwards to determine the concentration of the original acid. As I'll go through that in a moment. A couple definitions first. So we have the solution that goes in the burette, which is shown here. That is known as the standard solution or the titrant. It is the solution that we know the concentration of. An indicator is simply some chemical that's used to show the equivalence point. That's when we've used up exactly all of the starting acid or base if we were starting with an unknown concentration of base. And then the equivalence point, that's the point when the reaction stoichiometry is exactly balanced. So when we've added just enough base to react with all of the acid, with no excess reagent, that's technically the equivalence point. All right, so how do we go through and actually find the concentration from this information? So how exactly do we determine concentration from a titration? Well, we can use the following process, and you should use the following process. Many students are tempted to use the dilution equation to apply to titrations. Unfortunately, in the cases where you're titrating a polyprotic acid of some kind, the dilution equation does not work. So you must know how to go through this process to get to the correct final answer for that concentration. So the process that we do is we did the titration, and we know now the volume of the standard solution that we needed to reach the equivalence point. We know that volume of base that we dispensed to cause the indicator to change color and tell us that we've reached the equivalence point. Now, using the molarity of the standard solution and that volume, we use concentration and volume to figure out the number of moles. Remember, molarity is moles per volume in liters. So if you know the volume in liters and you know the molarity, then you can find the number of moles. So you find the number of moles of the standard solution, solute in the standard solution, in this case the base that you used. And then we should have a balanced chemical reaction that we can draw out, because we know what the acid is, we just don't know how much of it there is. So using that balanced chemical equation, we should know the coefficients of the acid and base, basically the molar equivalency, how much acid is required to react with base. Using that, we can convert from moles of the standard solution, in this case base, to moles of acid. That gives us the moles of acid in the solution that we don't know the concentration of. So now we know moles of acid, and at the very beginning we dispensed very carefully the volume of the acid. So we now know moles and volume. Molarity is simply moles over volume in liters. So we take the moles we have divided by the volume in liters of that acid, and that gets us the concentration of the unknown solution. Let's do this practically. So in a titration, we used 20.0 milliliters of 1.5 molar sodium hydroxide to neutralize 5.00 milliliters of an HCl solution. What is the concentration of the acid solution? So this is just like we showed in the example. The acid solution, HCl, is the one we don't know the concentration of. The standard solution is the sodium hydroxide. We know its concentration, and we did the titration to figure out the volume required to reach the equivalence point. And we know the initial volume of acids. So we simply follow our process down. First thing we have to do is write the balanced chemical equation. So I write this out. HCl plus NaOH goes to water and sodium chloride. Turns out that we have a 1-to-1 ratio here for these are the coefficients for HCl to sodium hydroxide. So I'm going to start with the volume of the standard solution and first convert that to moles. So start out with volume of sodium hydroxide. It's in milliliters, so I will convert it to liters. And I know the molarity, which is moles per liter. So I use that conversion factor now to cancel out liters and come out with moles of sodium hydroxide. Now I'm here. This is moles of my standard solution. Now I use the coefficients in the balanced chemical equation to relate moles of sodium hydroxide to moles of HCl. In this case, it's just 1-to-1. So the moles of sodium hydroxide, when I set this up, I cancel that out and come out with the same number of moles of HCl. This is the step where if we were dealing with a polyprotic acid, then the coefficients would not be equal. Now that I know the moles of HCl, I also know the volume of HCl, that's shown here. And I can convert this volume to liters and then do moles per liter, that's molarity, to figure out the final concentration. So moles divided by the milliliters converted to liters, and I come out with the concentration of this acid solution being 6.0 molar. So that's a little bit about how you do dilutions and how you do titrations in solution chemistry.